we are going to apply all the trigonometric ratios to what we call solve triangles using trig. So here is the review of all the stuff you've done so far. Remember the target angle? Yes. Remember how we label the sides? The hypotenuse. Across from the target angle, the opposite. And the one next to the angle adjacent. Do you remember those trig ratios? Sine of angle A. So I guess in this case I changed theta, because that's what I used here. Sine of theta would be the opposite divided by the hypotenuse. Cosine is the adjacent over hypotenuse. And tangent is opposite over adjacent. We've got some catchy phrase you can use here to memorize all these things. Many teachers use this thing. They use the first letter of each of these. So that's so to represent sine is opposite of hypotenuse. Then they use C-A-H, ka, to represent cosine. And then finally, there is T-O-A, toa. So, ka, toa. So, ka, toa. Say that a few times. Say it 10 times. So, ka, toa. So, today we're going to learn actually how to solve the right triangle. Solving means finding everything about the triangle, meaning finding all the unknown sides and all the unknown angles. Okay? Now, there are different ways to do this, but the good strategy here is to try to use the given information to solve your question rather than rounded answers that you found. Okay? And when dealing with trig questions, please don't round until the actual end. Okay? That's the way to keep as much accuracy as possible. So here's example number 1. Two sides are given. So let's draw this triangle. So side BC is 30, side AC is 17, and angle A is 90. So angle A is 90. I know that must be 90. Okay, and then I guess BC are just the two different things, B and C. Side BC is 30. Okay, there we go. And side AC is 17. So I took that information, I drew this triangle. And now our goal is to solve it. Find all the missing parts. Okay? Now, it doesn't matter which one you do first. So I'm just going to say, hey, let me do angle B. So I'm going to find angle B first. You don't have to. You can find angle C first if you want. You can find the missing side length AB. It doesn't really matter. But if I'm going to find out side length B, then I'm going to have to look at those numbers that I have, the 17 and 30, and ask myself, what do they represent? Hypotenuse, opposite, adjacent. Well, in this case, yeah, hypotenuse is 30, opposite is the 17, so which trig ratio do I use? Think so, ka, toa. So sine, that's right, sine of angle B equals to opposite over hypotenuse. And when you want to find the angle B, we need to remove the sine from the left side. We do that by taking the inverse sine function on the right side. And of course, calculator time. Whoops. What just happened there? Calculator time. Inverse sine, 17 over 30. Ta-da! 34.5 degrees. Okay? Now, I guess if you want to now find angle C, you could do that as well. But this time now I'm looking at this angle, and I'm thinking, yes, the 30 is still a hypotenuse, but look, the 17 is no longer the opposite side. It's now my, that's right, adjacent side. So remember, these adjacent and opposites can change depending on which angle you're looking at. So cosine of C now equals to 17 over 30. Look to see that I'm using the same information that I've been given. And C is the inverse cosine of 17 over 30. And on the calculator, that is 55.5 degrees. Okay? Now, Note, you could have also found angle C by looking at the sum of the angles in a triangle being 180 degrees. You could have taken 180, then subtracted 90, and then subtract your angle B, 34.5. That also would have given you C. Alright? So, once again, lots of ways to do this. Alright, now that you have the angle, you can actually find AB using trig. But what happens if I don't trust my answers? What happens if I don't really trust that these are right? So, if you wanted to find now length of AB with the information that you were originally given, then the only way I can do this now, because it's a right angle triangle, is to use Pythagoras. Okay? So once again, I'm using the original information. So a squared plus b squared equals to c squared. I'll say a is the one that's missing, 17 is my b, and 30 is my c. 30 squared is 900. 17 squared is 289. So a squared is just equal to 900 minus 289. I don't know that. Calculator time. 900 minus 289. 611. So a squared equals 611. A then equals to the square root of 611. And that is equal to 24.7 centimeters. Okay. Now you may be thinking, Mr. Lee, couldn't I have done AB another way? Yes, you could have, right? Knowing the angle now, right? Like knowing the angle of B, let's say that's 34.5, you could have figured out the adjacent side here and the hypotenuse by using cosine. So cosine of 34.5 equals to the adjacent, which is what you're missing, over 30. And if you do the calculations, you would have gotten the same answer. Don't believe me? Let me quickly type it into the calculator. 30 times cos 34.5. Same thing. Okay? I mean, you're off a little bit by the decimal, but you're close enough. So there are many ways to do these. And so don't think that the way I show you here is the only way. Okay? There are many ways. The other type of question you'll see is the one like this, where you're given one side and one angle. And you're asked to solve the triangle here as well. Okay? Well, in this case, I have an angle. This is the longest side of my hypotenuse. I guess I need to figure out, I don't know, I can call this x and y. Because the target angle is 51, x is my opposite side, and y would be my adjacent side. So, if I wanted to figure out BC first, I'd be thinking opposite hypotenuse. That's right. Sine. So sine of 51 equals to x over 26. And then we've solved enough of these questions, so I hope you can do this now. We'll cross multiply. So 26 times sine 51 degrees. 26 times sine 51. And there's your answer, 20.2. 20.2 centimeters. That is x, or BC. Then, of course, you can find AB. This time, I'm using the y and the 26. That's the adjacent and the hypotenuse, so that's right. Hello, cosine. Cosine of 51 is y over 26. And then you can solve this just like I did the sine question. Need my trusty calculator again. 16.4. Notice I've just used the information given in the question. Okay? And now finally I need to solve all three things. So I got all three sides, but I also need the third angle. So the third angle is C. And this is where I'll use the idea where the angles in a triangle add up to 180 again. So if I take 180 degrees, I subtract off the 51, and I also subtract off the 90, I'll get the answer for angle C. So 180 minus 90 is 90. 90 minus 51, that's just 39. And there you go. You've solved the triangle. Alright? Now, example 3, same question, but this time, no diagram. Oh no. So you have to figure out the diagram. I'll actually help you with the diagram, but after that, can you go ahead and solve it whichever way you wish, and then come back and double check your answer with me. B, C, D. Draw a right angle triangle. It's key to know which one is the right angle, so C. BC is 10, and angle B is 31. Okay, here's your diagram. Now the rest is up to you. Go. Maybe the easiest is to find the angle this time. So 180, take away 90, take away 31. I think that's 59. That's probably the easiest thing to do. I'm going to label these sides now. I'm calling CD X. And if I'm looking at the angle 31 here, X represents my opposite, and this represents my adjacent. So to find CD, I'm thinking opposite, adjacent, which ratio should I use? Oh yes, that lovely tangent ratio that we learned way back. Opposite over adjacent, cross multiply. Times tangent 31, 6 meters. Good. And now we need to figure out the hypotenuse. I'll call that y. This is the hypotenuse. Based on this angle of 31, this is still the adjacent. Once again, I'm going to use the information I have already been given. So to do that, adjacent hypotenuse, cosine, adjacent is 10, hypotenuse is y. Okay, once you set this up, once again, cross multiply. And this time we're going to take 10 divided by cosine of 31 degrees. And divided by cosine of 31 degrees, 11.7 meters. And there you have it. Okay, all right. Next one. Oh, some curricular competency questions. Anyway, here we go. This is an interesting window. It has a shape of a decagon. That's 10 sides, if you forgot. Deca is 10. It says the distance from one vertex to the opposite vertex. That's like this. Measured through the center is approximately 16 inches. And I want you to determine the length of wood molding material that forms the frame of this window to the nearest tenth of a foot. Oh, remember inches and foot. So remember, 1 foot is equivalent to 12 inches. So we're going to have to do some conversion at the end. You're thinking, I don't see my right angle triangle. You're right, you don't. Do you see triangles at all? If I were to do this, do you see a triangle now? Yeah. If the whole diagonal is 16, that means this is now 8. From here to there, right? To the center. So I see a triangle, that's great. But do I see a right triangle? Not yet. But if I were to cut it down the middle like this, then you do. Right triangle right there. Ta-da! Well, that's great. That's 8. But we need 2 pieces of information, not just 1. Oh, no. We don't know the other 2 sides. We want to find one of the sides. We have to have an angle here. Now, do you guys remember how angles at a point add up to? That's right, 360 degrees. So knowing this, can you see that I have 1 triangle, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles? So if I were to take the 360 and divide that by 10, you'll see that each of these triangles has a central angle when it touches the center of 36 degrees. So this entire angle here is 36, but that's still way too much, because for my right triangle, I'm only using half of it. So for the right triangle, okay, you see I have to now take the 36 and divide it by 2, which is 18 degrees. So with that, what I want you to realize is that this blue triangle that I just created here, the length is 8. This angle now is actually 18 degrees. And this is helpful because now I think I can find out this length, x, which is equivalent to half of the molding of one side. So how do we figure out x? Here's 18, that seems to be the opposite side, and 8 represents the hypotenuse. Opposite over hypotenuse, that's sine, or so. So x equals to 8 times sine 18 degrees. I can calculate that, 8 times sine 18. I get 25.888, so 25.9. And of course this is inches. That equals to x. Okay, now how much crown molding do I need? Well, if this is x, that's 1, here's 2, here's 3, here's 4, here's 5, here's 6, here's 7, here's 8, here's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 x's. So the entire perimeter is actually 20 of those x's. So 25.9 times 20. Actually, it'd be better if you just kept the decimal and times it by 20. That gives you a more accurate answer. 517.77. This is inches. And then finally, we need to convert to feet. Wow, crazy question. And we can do that by dividing it by 12, because there are 12 inches in each foot. So dividing by 12, wow, 43.1 feet. And that's how much molding or the wood material is required. Awesome. Awesome, awesome, awesome. So, we'll look at example number 5 now. Okay, perimeter area again, this time of an isosceles trapezoid, so I don't know if you've seen that before. Shorter side has 12, the height is 4.6, and his base angles measure 55, so this is 55, and this over here is also 55, so those two triangles are actually the same. The question is find the perimeter and the area. We need to find out pretty much both of this here, which I'll call L, and this part here, which I'll call H. So focusing on this triangle here, 4.6 LH, and then this is 55 degrees. Okay? So let's figure out L first. L would be the adjacent side. If I look at the 55 as my target angle, so adjacent over, and I guess I can use, what's this? Oh, 4.6 is opposite. Opposite over adjacent. Yeah, tangent 55 equals to opposite 4.6 over adjacent, which is L. We'll multiply both sides by L. Divide both sides by tangent 55. All the stuff we've done so far. 4.6 divided by tan 55. Voila, 3.22. Okay, centimeters. That's not it. We need to find more than just L. Let's go ahead and find H. I'm going to use opposite on hypotenuse, so that's sine. Sine of 55 now equals to 4.6 over H. Same methods of calculating. So what is this? 4.6 divided by sine 55 5.62. All right. Now that we have this, I think we can figure out the perimeter and the area. The perimeter, first of all. Let me go up here now. Perimeter. That's all the sides. Got your length, 3.22. Got your hypotenuse, 5.62. Now you got your 12, plus another hypotenuse, plus another length, plus another 12. Calculate. 2 lengths, 3.22 times 2, 2 12s, and 2 hypotenuses. I feel like I'm ordering from McDonald's or something. I want 2 of these, 2 of these, 1 of these. 41.68 centimeters. Area now, notice it's made up of the 2 triangles plus the rectangle. The triangle area, once again, is length, 3.22, times height, 4.6, divided by 2. The rectangle is just 4.6 times 12. So let's see what we get here. 3.22 times 4.6 divided by 2. 7.406. Plus 12 times 4.6. 55.2. And another 7.406. We'll add that all up. Dun, dun, dun. 7.406 plus 7.406. Wow, 70.012. And don't forget centimeters squared. Yeah. All right. One more. This one is really interesting because you're going to have to use information that you might have done before or have visualized. I don't know if you've made cones before from paper. And you actually cut something out like this, a 3/4 of a circle. And then you actually take these 2 sides and stick them together. And when you do that, you actually form a cone. Okay? So when you do this, you're going to get this lovely picture instead, a cone. Okay? Notice that the highlighted side there in yellow will be actually become the slanted side of your cone. So in this case, my question is, can you calculate the base radius of the cone? So can you actually calculate the radius of this? And if you're thinking, where in the world did this circle part come from? Well, that circle part is really equivalent to the outer edge of the shape that you just did right there. Because when you put the yellow pieces together, the circular pieces also connect, and that becomes your circumference. That's right. Now, if you want to calculate the length of this piece, this is 3/4 of a circle with radius 16. So notice that the key formula that hopefully you remember from way back, circumference of a circle is 2 times pi times r. So 2 times pi times, in this case, r, which is 16. 2 times 16 is 32 divided by 4 is 8 times 3 is 24. This is equivalent to 24 pi. That distance in blue. Now I told you that's exactly the same as the circumference here. So for part A, the circumference, which is 2 pi r, this little r, is equal to, well, the circumference is 24 pi, so hopefully now you can solve for r. By dividing both sides by 2 pi, you figured out that r equals to 12. Nice. Now, knowing that r equals to 12, part B says find the height of the cone. Here's the height. So r is 12. The height is what's missing. And we know that the slanted side there is equivalent to 16. So there you go, 16 squared. So h squared is just 256 minus 144. 256 minus 144 is 112. So take the square root of 112, and then you get approximately 10.58. Cool. And the angle of inclination. So now finding the angle of inclination. Look at that triangle again. We knew this was 16. We knew R was 12. We knew H is 10.58. So you have lots of options. If I'm going to take the nicer numbers, I'm going to use that. And I'm thinking, there's my target angle. Here's my adjacent and hypotenuse side. You got it. Cosine. You got it. You can do it. Your calculator can do it. Wow, 41.4 degrees. This was a lot. Okay, digest this, please. And then when you're ready, try these here. We're almost done. Okay, I think there's only one section left, so you're near the end.